structure of benzene. We are giving analytical, synthetic and other evidences to derive the structure of benzene. Why this derivation of structure of benzene was so difficult? Now we have various equipment, instruments, analytical, which can analyze the structure of the molecule. Benzene was isolated in 1825 by Michael Faraday, given and its molecular formula was given as C6H6 by Elucidation. This structure was elucidated based on the analytical and chemical tests. Here, the molecular weight determination showed that the molecular weight of benzene was 78, and the elemental analysis revealed that the percentage of carbon was 92.3 and 7.69% respectively. By correlating the molecular weight and the percentage of carbon and hydrogen by the element which we got from the elemental analysis, the molecular formula was deduced as C6H6, which indicates that it is a highly unsaturated hydrocarbon. Based on the molecular formula, the 5 structures were proposed. These are the 5 structures which were proposed to be probably the structure of benzene looks like this. The first 2 structures were open chain structures, and next 3 structures were the cyclic structures. Here the 4th structure is proposed by Dewar and the 5th structure was proposed by Kekule. Out of this 5 structure, one can be a molecular structure of the benzene. Out of this, which is the structure of benzene? It was elucidated based on the following facts. Benzene, when it was treated with bromine in the carbon tetrachloride, it should decolorize the color of bromine. If it is treated with potassium permanganate, it should decolorize the color of potassium permanganate, provided they have double bond in the system. But that reaction did not occur at all. What it indicates? It is a benefit of doubt that is double bond present in the molecule, but all the proposed molecule structure has double bonds in it. But the test for unsaturation was negative. Now the doubt is double bond is present or not. Further, when benzene was treated with chlorine in the presence of UV light, it gave hexachlorobenzene. Benzene, when it was treated with molecular hydrogens at the 500 bar atmospheric pressure and 150 degree temperature, it gave cyclohexane. Formation of cyclohexane indicates that benzene can be a cyclic ring structure. Means the first 2 structures which were open chain structure can reach 4 moles of hydrogens. That's why these 2 structures were rejected. Structure 4, which is the Dewar structure, which is having 2 double bonds, means it can consume 2 moles of hydrogen. That's why it has consumed 3 moles to give cyclohexane. Means structure 4, Dewar structure, has been eliminated as a structure of benzene. Benzene further reacted with bromine in the presence of catalyst FeBr3 to give bromobenzene. In the presence of FeCl3, it reacted with chlorine to give chlorobenzene. In this reaction, what is happening here is one of the H is replaced by Br. H plus is replaced by Br plus. It is undergoing electrophilic substitution reaction. This electrophilic substitution reaction can be possible in the cyclic structure 5, which is proposed by Kekule. That's why it is said that it probably the structure of benzene can be the Kekule structure. the structure proposed by Kekule. Further, benzene, when it reacted with 2 moles of bromine, it gave corresponding 3 isomers of dibromobenzenes. These isomers were found to be 1,2-dibromobenzene, which is represented as number 6, 1,3-dibromobenzene represented by structure 7, and 1,4-dibromobenzene represented by structure 8. By assuming Kekule's structure is right, these 3 isomers could be proposed. But however, in ortho isomers, 1,2-dibromobenzene, this is also 1,2-dibromobenzene, 6A, 6B is also 1,2-dibromobenzene. They are isomers to each other. These isomers, 2 ortho isomers can be possible. This, how it is possible, this was not able to be explained by Kekule. That's why it was said that it was not able to explain and he could not give the exact structure. Then in the next Bayer gave the synthetic evidence. He took acetylene and passed on the hot tube of copper or iron at 873 degree Kelvin and it cyclized to give benzene. This is an evidence to show that benzene has the structure which is proposed by Kekule. This is the synthetic evidence. Right. Now, the formation of 2 isomers of dibromobenzene was not able to be explained by Kekule. Hager suggested that Kekule's structure is partially right. He further said that double bonds in this proposed structure by Kekule is not static. It is instead dynamic. It is dynamic because it is stabilized by resonance stabilization. The benzene ring, the pi electrons can move over here, then these electrons can move and these electrons can move to give rise to this structure. This is also structure of benzene, this is also structure of benzene. Means the pi electrons are not static, they are keep on moving. That's why benzene is a dynamic structure. Hence, benzene is represented as a 6-membered hexagon with a round circle in it, which represents the pi electron cloud. 3D structure representation we can give in this fashion. Hence, the proposed structure of Kekule was accepted by the scientific community. But however, there was no experimental evidence. Later on, with the advent of X-ray diffraction, the differential studies of benzene was carried out. And based on that, it is said that carbon in benzene ring is in sp2 hybrid form. One of sp2 hybrid orbital combines sp2 hybrid orbital of another carbon and both the sides. Here there is a p orbital adjacent to this sp3 hybrid orbital. The 3 sp2 hybrid orbital which are combined with carbon and one more sp2 hybrid combines with s orbital of the hydrogen. The p orbital which is available is perpendicular to plane of this ring system and they overlap sideways. That's why there is a pi electron cloud across the benzene ring system. The carbon-carbon bond length of benzene is found to be 1.39 angstrom units. The bond length is in between the bond length of a double bond and a bond length of a single bond, which lies between 1.34 angstrom to 1.53 angstrom unit. As it is sp2 hybrid carbon, it has a bond angle of 180 degree. That's why Based on all this fact, the X-ray diffraction studies indicated that this is the structure of benzene. Thank you.